Good morning, students. I am Nidhi Bagalwadi, your science teacher, Sankalp Learning Solutions. In the last class, we discussed the resistance as well as the resistors when they are connected in the series. What will be the total resistance will be, and also we derived a formula regarding it. So from that we got to know that the resistors when they are connected in the series, the total resistance will be the sum of the resistances of the resistors which are connected. And in that case potential difference will not be remain constant and the current in the circuit will be constant. This all we learned in the previous session. Today we are going to solve two numericals based on that formula. Later we are going to learn regarding the parallel combination series of resistors. Okay. So let us begin for that. For the numericals I selected the problem from your textbook in text, that is from page number 212, that is 12.7, example 12.7. So the question goes like this: an electric lamp whose resistance is 20 ohm. They selected a lamp, okay, its resistance is 20 ohm, so we have to take this as R1, okay, and a conductor of 4 ohm, and they selected a conductor. Conductor means not only which passes the current, it will be also having certain resistance, it also offers certain opposition for the flow of current. So that is 4 ohm resistance are connected, both are connected to a 6 volt battery, means the total potential difference in the circuit is 6 volt. Calculate the total resistance. Rs we have to calculate. The current through the circuit. Is we have to calculate. Potential difference across electric lamp and conductor. That is V1 and V2 we have to calculate. So let us proceed. As they asked electric lamp, so usually we should uh, consider it as V1. So let us proceed. Let us write what is given. So the given here is first one, the resistance of a bulb, of a lamp, right? The resistance of a lamp. So it is around 20 ohm, which is considered as R1. So it is around 20 ohm. Just a minute. Okay. Next we have the conductor. The conductor which has resistance has R2. So that is equal to 4 ohm. Then potential difference, or the battery has a potential difference of, so we can consider this as Vs in a circuit, it is of 6 volt. So what we have to find? The first one they asked is resistance in series Rs. The second they asked is current in the series Is, we can write. The third one they asked is potential difference across electric lamp and conductor. So we should take it as V1. So first let us solve for resistance in series. So we know that, right? In series combination, the total resistance, what is total resistance? That is nothing but the Rs. Rs is equal to sum of resistances, that is R1 plus R2. What is R1 here? It is 20. What is R2? It is 4. So the resistance in series will be 24 ohm. Okay, Rs is equal to 24 ohm. Fine. Okay, this is the first one we saw. Next they asked current, that is current in series Is. So we know that Is, V is equal to I into R. So we can write it as V is equal to I into R, means I is equal to Vs by Rs. Okay. So what is Vs here? We have 6. What is Rs? We got 24. 6 ones are 6 fours are. When we simplify further, we will get it as 0.25. As it is current, The SI unit is ampere. So IES, that is current in series, we got it as 0.25 ampere. This is the second one. Then third, they asked regarding V1. V1 is equal to, okay, so that is I into IS, because current remains constant in series combination. That is why we should consider it as total current IS into R1. IS is what it is, 0.25. R1 is nothing but 20. Okay, R1 is 20. So when you simplify, how much you get? 0.25 into 2. When you do, you will get around 0.5. Okay, 0.5. 0.50. 0.500. Okay, 0.500. Okay, so this is V1. V2 if you want to find, so IS into R2. So what is IS? 0.25. What is R2 here? It is 4. So when you calculate, it will come around 1 volt. It will come around 1 volt. Okay. Now, so when you multiply 25 into 20, see here, 20. Okay, first one is 0. Then plus 2 5s are 10, 2 2s are 4 and 5, 2 zeros are 0. 0 0 5 0. After 2 decimal, 5.00. So it is not 0.5, it is 5.00, means 5 volt. So you will get it as 5 volt, V2 as 1 volt. Okay, rectify it. Okay, 5.00, it is 5 volt and this is 1 volt. So this is how we have to solve the problem. And while solving the problem, it is better to draw the circuit diagram. It helps us. So when you draw a circuit diagram for this, it will be helpful, so that sometimes they will ask draw a circuit diagram. So here a resistance and the lamp is connected, ammeter, the key. If you just draw a rough diagram also, so this is 6 volt, this is key, this is ammeter, this is R1, you can say this is R2 you took, this is R1. You can write the values over there. So like this you have to draw the rough diagram so that it will be easy for us to solve. Okay, now the next question I selected it from the exercise, that is the 9th question. So let us solve it. So in the 9th question, the 9 volt battery is connected. So in the 9th question, 9 volt battery is connected. So given is here Vs, it is connected in series. Vs is equal to 9 volt. Then they have R1 as 0.2 ohm, R2 as 0.3 ohm. Okay, then R3 as 0.4 ohm, R4 as 0.5 ohm. Okay, then R5 as 12 ohm. So the 5 resistors are connected in series to a 9 volt battery. Fine. Next, what we have to find here? To find I think current, right? How much current would flow through the resistor? That is I through current through 12 ohm resistor we can write. Okay, so as we know that in the series combination, current remains the same. Current will not be divided or distributed, right? So here total we can find, if we find the total current in the circuit, it will be the current flowing through the resistor which has 12 ohm. So let us do that. For that, let us consider or let us find RS first. So we know that in a series combination, in series combination. Okay. So RS is equal to, resistance in series is equals to R1 plus R2 plus R3 plus R4 plus R5, because we have 5 resistors here. Okay, so when you add all those, zero point 0.2 plus 0.3, 0.5, 0.5 plus 0.4, 0.9, 0.9 plus 0.5, 1.4 plus 12. So when you add this, you will get around 12.0, 1.4. So it is 13.4 ohm. So resistance in series, the total resistance is 13.4 ohm. So using this we can calculate current. So we know that Is is equal to Vs divided by Rs. Vs is also always given, that is already given, 9 by 13.4. 9 by 13.4. So when we solve for this, we will get it around 0.671 ampere. So current through 12 ohm resistor will be 0.671 ampere. Okay. So like this we have to solve the problems based on the combination of resistors. First we have to write given, then if possible, if it is sum which involves to find many quantities like resistance, current, etc. So in that case, please do draw the diagram, circuit diagrams. Then after that we can solve for the quantities which we have to find, the values like resistance and current. Okay. In the next session, we are going to learn regarding parallel combination of resistors. Until that, take care. Have a nice day. Bye bye.